Hi guys, in this video we're going to have a look at area of segments. So just a quick reminder, a segment is this area here. So if you have a chord going from one point of the circumference to the other, the area above it we call the segment. Obviously this can also be a segment as well. This would be the major segment, this would be the minor segment, but this area is the one that's shaded and that's what we need to work out. Now before we get cracking, you will need to know how to use these formulas here. So it's the half AB sine C formula, so that's the area of a triangle. So have a little look at that video before doing this because we will be using that. And also the area of a sector, which is theta divided by 360 times by the area of the circle, so times pi r squared. Okay, so we are going to be using those two, so definitely make sure you're familiar with them before watching this video. Okay, let's get cracking then. So I've got a few examples of working out the area of sectors, and then I'm going to go backwards and work out some angles and some lengths. So if you want to skip to the harder stuff because you're happy with this, by all means do so. But for now, let's crack on with this first one. So to work out the area of this shaded segment, I'm going to work out the area of the whole sector. Then I'm going to work out the area of the triangle and then take the two away, and what's left will be the segment. So here is my sector. I'm just going to do a very quick sketch here just to show the examiner that's what I'm doing. So here's my sector, and that's going to be using this formula here. So I have my angle of 130. I divide that by 360 because that's going to be the whole circle. Times that by pi, times it by the radius. In this case, the radius is 10, so times that by 10 squared. Okay, and if we do that with our calculators, we're going to have the answer of 113.44640014. Okie dokie. And once I've done that, I then need to work out the triangle. So I'm just going to draw a little sketch of a triangle to show that's what I'm now doing. And this is where we use the half AB sine C rule. So it's a half times 10. This will also be 10 centimeters because they're both radiuses. So times 10 times 10 times by sine, and the angle is 130. And if we put that into the old calculator, so we've got a half. You can use 0.5 for that, to be fair. Probably be a bit quicker. And close the bracket. We have 38.30222. How many are there? 416. Okay, and then all you got to do is just take the 2 away. So that's what I'm going to do here. So 113.44, etc., etc. Take away the 38.302, etc., etc. Now notice I haven't got rid of that on my calculator because I'm just going to type in this number, 0.4464014, and then minus, and then I press the answer button, it'll use the previous answer, and that's going to give me the most accurate answer there because I haven't rounded until the very end. So 75.144177, etc. And obviously the question might round to one significant figure or two significant figures or one decimal place. I like to round to one decimal place. So the first decimal place there is 1. 4 would tell you to round down. So 75.1, and of course its area, so centimeters squared. Okay, let's have a go at the next one. So exactly the same thing. Let's work out the total area, which is the sector. So 65 divided by 360 times by pi times by the radius, in this case is 5, squared. Let's see what that comes up with. 65 over 360 times by pi times by 5 squared. I'll leave it in terms of pi, so that's 325 over 72 pi. You can use decimal if you want, you can write that whole thing out, but it's just using less space here. Then we need to work out the triangle. which is half times 5, and obviously that will be 5 as well, so times 5 times 5 times sine 65. Don't forget to close that bracket. So I'm going to use 0.5 this time. You can use half, again, whatever works. Times by sine 65, close that bracket, and that equals 11.3288474. And all I'm going to do is take the 2 away. So just draw a little diagram here if you like. That one, take away that one. Obviously in the exam, write it out properly. I'm just going to do the diagrams because I'm running out of space. And so we had 325 over 72 pi, and then we want to take away our previous answer, leaving us with 2.851952, etc., etc. Again, I'm going to round to 1 decimal place. 8 is the first decimal place. 5 tells us to round up. 2.9 centimetres squared. Okay, and we'll have a look at this one. Be careful though, some people just go straight into this without really thinking about it, but the angle we've been given there is 200, but I need the angle that's inside the sector and inside this triangle. So 360 is the whole thing, so 360 minus 200 leaves me with 160 as my angle. So just a little one to be careful of there. Don't fall into that trap and use 200 as your angle. Very easy, and you will end up making obviously a mistake in your final answer. So let's work out the sector. So we have our angle of 160, which we were very careful not to fall into that trap, times by 6. Times by pi times by 6 squared, which gives us times by pi 16 pi's. That's nice. And then we need to work out the triangle, which is a half times 6 times, and this length here will also be 6 times sine 160 in brackets. So 0.5 times by 6 times by 6 times by sine 160, and that is 6.1563, etc., etc. And as with before, take the area of the sector, which is 16 pi, take away the triangle, write that out in the exam. I'm just doing that because I haven't got space, just like before. So 16 pi, take away my previous answer, or take away this here, and you're left with 44.109, 1 decimal place, so that does continue, leaves us with 44.1 centimetres squared as your final answer. Okay, so there's some of the basic ones, just plugging it straight into the 2 formulas and then taking them away. Let's have a go at some missing lengths ones. Okay, so here we go then. Here is a missing angle, and we're going to work out that missing angle. Okay, to do that, we are told that the area of the triangle is 42.25 centimetres squared, which we're going to need, and we need to work out the area of the shaded. So we need to find out the area of the angle, work out the value of the angle before we can then work out the area of the segment like we've been doing. Now, because we're told the area of the triangle, we're going to use our half AB sine C formula, because that tells us what the area is, and we've been told that. So that's our clue into the question. We're told the area of the triangle is this, so that's going to have to be our starting point. We're going to have to use this formula. So let's substitute in what we've been told. Well, obviously a half is just a half, times the AB, so times 13 times 13, that bit's fine, times by sine, we don't know what the angle is, so leave that as theta, and that's then going to tell us the area, which we know is 42.25 0.25. Okay, then it's just a simple bit of simplifying and rearranging to solve. So let's do that. So 0.5 times 13 times 13 can be our starting point, and that gives us 84.5 sine theta equals 42.25. So all I've done is just simplify this bit here. I want to get rid of it because I want to get theta on its own, so I'm going to divide both sides by 84.5, like so. So sine theta will equal, so 42.25 divided by 84.5 is a half. Oh, that's nice. Oh yeah, of course, sorry, I'm being silly. And then hopefully if you remember your trigonometry, when you need to work out the angle, we need to do the inverse sine. So I'm going to inverse sine both sides, which is that little -1. And therefore theta equals inverse sine, and in brackets a half. So the angle, remember to get the inverse we do shift sine, and you should see the little -1, and then obviously a half in there, and that comes out at 30 degrees. Okie dokie. So now we have the angle, we're in business. We can work out the sector. So the angle is 30, so 30 divided by 360 times by pi times by the radius squared, so times by 13 squared. What does that give us? 30 over 360 times by pi times by 13 squared. So that gives us, I'll leave it in terms of pi, 169 over 12 pi. So all I need to do now is I now know the sector. I don't need to work out the area of the triangle because it's already told me that. So now I literally just do this, take away the area of the triangle. So 169 over 12 pi, take away the area of the triangle, which we already know because we've been told that. And I can just literally just take away 42.25 there on the calculator, and it leaves me with 1.99409, etc. So to one decimal place, 9 tells me to round that up, that becomes a 10, which means I need to be 2.0. So if it's one decimal place, leave it like that, and its area, so centimetres squared. Okay guys, that is area of segments. Hopefully that helps. Thanks for watching.